Hello, let's continue our Sudoku adventure with Cat on a Box by Jean. So we're back to our normal rotation of puzzles, so this does not necessarily involve parity. Let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these gray lines in the grid, and they have may or may not have crop key on them, these dots. So let's go over what white dots and black dots mean. So if you see a white dot, that means that the two digits in the solution are consecutive across that white dot. So if this was a 2, this would have to be a 1 or a 3 in order to be consecutive with the 2. 2, 3, or 1, 2. Order doesn't matter. And then the black dot means that the digits have a 1 to 2 ratio. A good way to put that is one of them is exactly double the other. So if this was a 2, this could be 1, 2 is double 1, or this could be 4, because 4 is double 2. Now, you'll notice that dots are only ever on lines, and on that line, all of the dots are given. So, for example, if this was a 2, there is not a dot across here, so I cannot put, for example, a 4, because if this was 2, 4, we would have expected a black dot, and there isn't one, so I'm not allowed to do 2, 4. We also can't do 2, 3, because we would expect a white dot. Over here, I can do 2, 4. There isn't a black dot, but it's also not on the line. So it's only on the lines that we expect all of the dots to be given. All other dots are not necessarily given. So we can do 2, 4, and that would be fine over there. What we can't do is 2, 4 here, because we would expect a black dot because it is on a line. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, how shall we get started? Is there something special about a black dot and a white dot in the same box? So black dots in general we can talk about. There's always going to be one low digit and then one even digit on the line. Across the dot. Right? We don't know if this is the order, but we're always going to have a 1, 2, or 3 because if the lowest, but by definition, the low digit is the one that gets doubled. Because if we're doubling the high digit, then that's not the high digit anymore. We just doubled it. So the low digit is 1, 2, or 3. And then we're doubling it to make an even digit, 2, 4, or 6. So we can do 1, 2, 2, 4, or 3, 6. Those are the options. Now you'll notice the only one that doesn't use the 2 is the 3, 6. So, and you also notice that we cannot put a 5. There is no way for 5 to exist because 5 is not low and 5 is not even. So we also know that a black dot has at least one even number on it because we're doubling a digit. We can have 2 evens if we're 2, 4, but we can't have 2 odds. A white dot always has exactly one even and one odd because they're consecutive. So either you're starting with an even or you're ending with an even with a consecutive. So what do we do with that? This is interesting. Okay, so we have 3 digits here. So just the roping in 6x6. What's roping? Well, whatever these digits are, they have to go in this box somewhere, and they end up here. So in 6x6, you end up with this automatic roping. So we know that these green digits are the same as these green digits. And these green digits, at least the way they're placed right now, do not have any white or black dots between them. Okay, I'm not sure that that immediately does anything for me. It's got to be box 1, but I'm not quite seeing it yet. Let me think about the 2, 4 case. If this was 2, 4, then these are odd, 1, 3, 5, because we have the other even on here. In fact, the other even is 6, so this would be 5, 6. So we'd have 2, 4, 1, 3, and 5, 6. Now, does anything violate here? We have to be careful here and here because we don't want to be consecutive. So for example, if this ended up being the 1 and the 3, then we couldn't put the 2 here. This would be 4 and so that doesn't actually work. Oh, interesting. Yeah, because okay, so here's the way to think about it. Oh no, across here we don't care. It's across here that we would care. Right, the line doesn't go across there. So across, sorry, I was doing full. Okay. So maybe this does work, but here's something that we can think about, which is whether this is 2 or 4, this can't be a 3 because they would be consecutive and there's no white dot. So this is never a 3 if this is a 2-4 pair. This would be 1, this would be 3. Now the 1 forces that not to be 2. So that's a 4 and that's a 2. And that's 2, 3, but that's okay because there's not a line between them. Now 3 can't go next to 6. This would be 5, 6. So this is one way to resolve 2, 4, 1, 3, 5, 6. And that seems to work okay. As far as I can tell, if we follow the line, 2 to 4, 4 to 1, 1 to 3, 3 to 5, 5 to 6. Okay. So 2, 4 works. I guess we should think about 3, 6 maybe. Maybe I can force a 2 onto here. Maybe I'm trying to make one of these not work. So 3, 6. This could be 1, 2. It could be 4, 5. So we're dealing with like embedded cases here. The problem with 3, 6 is it doesn't eliminate anything from this cell. This can be anything. Okay, so there's one case, which is this would be 1, 2. And so 1, 2, 3 are gone. This would be 4, 5. Okay, and that doesn't work. Oh, right. Okay, so 3, 6 doesn't work because there's two. The two groups left here are 1, 2, and 4, 5. And so no matter which one I pick here, this is going to be the other one, and it's going to be consecutive, but there's no white dot between them. If I pick 1, 2, this ends up 4, 5. If I end up with 4, 5, this ends up 1, 2. And those are the only two cases because we have 1, 2, 4, 5 left. We can't use 3, 6. And so the only way to be consecutive is one of those two. And that puts the other pair over here. So 3, 6 doesn't work. So we definitely have a 2 on here. And so this is from 1, 2, 4. Now I guess I could look at 1, 2 to see if that does anything, but 1, 2 feels very open to me. Does it break down here maybe? I'm not sure. This is very long. Okay, so I've learned that there's a 2 on here. And I've learned something very specific, which is that if it's 2, 4, there's only one way this resolves. Interestingly, if this is 2, 4, not only is this 5, 6, but this is also 5, 6. So I wonder if that breaks something. What's left here? The 1, 3 and the 1, 3. So we said that 1 and 3 eliminates 2. So this is 4 and this is 2. But that seems to work okay. The 4 makes both of these a 1, making both of these a 3, making both of these a 5, and both of these a 6. So 2, 4 does a lot, but it doesn't seem broken to me. Is it the fact that this ropes down to here? This would have to be 2, 3, 5. So the 5 has to be between the 2 and 3, for sure. And then this is 1, 4, 6. This couldn't be the 4 or 6. Oh, no, sorry, this doesn't care. 2, 3 only eliminates 2, 3. I mean, I think this works. It may be the solution, but I can't prove that. Maybe I need to prove that 1, 2 doesn't work before I can continue. Unless 1, 2 is it. See, I don't know. So I have to avoid this being 3, 4 because that makes this 5, 6. And I have to avoid this being 5, 6 because that makes this 3, 4. So we end up with 4, 5 only here, actually. So this always has a 5 on it because 2, 4 forces 5, 6 and 1, 2 forces 4, 5. Now this 4, 5 then means that this is, oh, that doesn't work either. Can't put a 3, 6 here. Okay, so I discounted 1, 2. 1, 2 doesn't work. I thought there were a lot of options, but there's not. So just to go over it again, these need to be consecutive. If I make it 3, 4, this ends up 5, 6, that's consecutive. That's no good. If I make it 4, 5, these end up 3, 6, that's a 1 to 2 ratio. That's no good. If I make this 5, 6, then this is 3, 4, and that's consecutive. So 1, 2 doesn't work. This is 2, 4, and then we can just resolve it one last time. This is 5, 6, this is 1, 3. And now we can see that whether this is 1 or 3, this can't be 2 because it would be consecutive with it. So that's 4 and that's 2. 4 can't be with 3, so that's a 1, that's 3. 3 can't be with 6, so that's 5 and 6. Now we end up with the exact same thing down here. This is 5, 6. This is 1, 3. 4 can't be next to 3. So that's 1, that's 3. 3 can't be next to 6, so that's 5, that's 6. Now down here we get 2, 3, 5. And we have to separate the 2 and 3 so that they're not next to each other. So we have to put the 5 in between them. All right. And now this is 1, 4, 6. And I don't think there's any immediate way to resolve the 1, 4, 6. Okay. The 2 will be next to the 6, actually. So we can do one elimination. If this is 2, both 1 and 4 would be a black dot with 2. And the 1 would even be a white dot also. So this would be a 6 only. And so wherever the 2 ends up, we put the 6 above it, which means this is not a 6. That does mean we need a 6 down here somewhere. In fact, one of these 3, because of this 6. All right. I wonder if there's more I can do here. Now, I don't know whether to do this column or... Let's see. I wonder if this column's interesting. We just don't have a 5. So the 6 can't go next to 3. The 2 can't go next to 1 or 4 or 3. Okay, so what's the 2 going to go next to? Is kind of the first question. We're ignoring everything over here. We're just doing this in isolation. We don't have a 5. So what's 2 going to go next to? Not 1, because we're ignoring this. Not 1 because of the consecutive. Obviously not 2. Not 3 because of consecutive. Not 4 because black dot. Not 5 because there's a 5 here. We are using this 5. So 2 has to go next to 6, which means that it's at one of these ends. Because otherwise it would have to be surrounded by 6, which is no good. So one of these 2 is a 2. And then that's going to put a 6 next to it. So we're going to go 2, 6. Let's just go from one end. We go 2, 6. Then this wouldn't be the 3. So this would be the 1 or the 4. And then we have the 1, 4 pair. So then we need the 3. So then this wouldn't be the 4. So this is always a 4. So we're either going... let me make sure that's right. So if we go 2... We have to put 6 next to it. Now, next to this 6, and we're ignoring all this stuff over here, next to this 6, we can't put the 3. So what's left is 1, 3, 4, right? We can't put the 3 next to the 6. That makes a 1, 4 pair. That makes this 3, which means this can't be 4 because they're consecutive. The only other option is I'm just going to use this column as a scratch, is to put the 2, 6 here, and then now this has to be the 1 or 4, and it would make a 1, 4 pair, because remember, we're just pretending it's over here. And that would be 3 in that. So it does the same thing each way. And so we end up with 2, 6, 1, 3. So we have the 2, 3 pair, the 1, 6 pair, and this is the 4. Okay. Very interesting. In order to do that, I had to have actually figured out that wasn't 6. So that was a good thing that I did that. Now we don't know which way this goes. Nothing over here is resolving it yet. This isn't 3 or 5, but it isn't by Sudoku, so it doesn't matter. Do we have... Okay. Where's 5 in this box, then? This 5 looks down, this 5 looks in. Can't put a 5 on a black dot, so that's our 5. And then that puts a 5 in one of these 2. So what goes across this black dot? Well, okay, so it's not 3, 6. That's the point. Right, because the 6 is used. So it's going to use the 2. And if this uses the 2, we can't also put a 2 here. So this resolves as 3, 1, 6, 2. Very nice. And so what's left here? We need the 1. Oh, the 1 is placed. That's not 1, that's not 1. So we need the 1. That puts a 2 next to it. That's 3 and 2. And then this is 4. Okay, that works. So up here we need 2 and 3. We know the order. That's 2, 3. It's okay because there's no line there. Over here, we need 4 and 6. There's no lines connected, so Sudoku's going to have to resolve that. Here we need a pair. We have 1, 2, 3, 4. We need 5, 6. Oh, so that's the 5. That's the 6. I wonder if I needed that line. All right, that's 5. This 2 looks over. That's 2 and 4. This is now a 3. Over here, we need a 1 and 4. So, up here, the 3 resolves the 6. Or it can't be 6, so that's 1, that's 6. That's 4, that's 1, that's 6, that's 4, and we're done. All right, cool puzzle, Gene. I enjoyed that. Had to think about this. The fact that it could only be 2, 4 was very interesting. I don't know if there was like a cleaner way to do it besides the case checking I did, but I don't think the case checking was too bad. Cool. Well, let me know how you did, and if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.